Our vision feels so effortless, doesn't it? But behind every single glance, there's this incredibly complex command center working overtime. Today, we're going to pull back the curtain and demystify that whole system. We'll get into the pilots that steer your eyes, find out what happens when they lose control, and explore the amazing science that can bring sight back from the very brink. So let's just start with a really basic question. As you're watching this right now, what is physically piloting your eyes? Is it, I don't know, a single muscle? Is it just your brain sending out direct orders? What do you think? What's the magic number? The answer is 3. That's it. Just 3 crucial nerves are responsible for that whole intricate dance your eyes are doing constantly. Their coordination is absolutely everything. So come on, let's meet these pilots. Okay, so these 3 pilots are what we call cranial nerves. And you can think of them as the direct data cables running from your brain straight to the muscles moving your eye. I mean, they handle everything, from tracking a car as it drives by to instantly shrinking your pupil in bright light. They really are the absolute foundation of our entire visual control system. And here they are, the big 3, the oculomotor, the trochlear, and the abducens nerves. Now, each one has a super specialized role. They coordinate the 6 different muscles that move your eyeball. They control your eyelid. They even manage your pupil's reflexes. It's this tiny but incredibly mighty team that does it all. So that's the system when it's all working perfectly. But what happens when that connection to one of these pilots gets damaged or interrupted? Well, that condition is called a cranial nerve palsy. And sure, it can be caused by an injury, but a lot of the time it's actually a warning sign for a bigger issue, like uncontrolled diabetes or high blood pressure that's messing with that vital connection. Let's kick things off with the big one, the oculomotor nerve. You can really think of this as the workhorse of the group. It controls most of the eye's muscles and the eyelid. So you can imagine if this pilot loses control, the signs are going to be immediate and pretty significant. Okay. Now, what's so fascinating here is how each physical sign you see on the left creates a very specific problem on the right. That drooping eyelid, that's the most obvious clue. But because the muscles it controls aren't working, the eye literally drifts down and out, which causes this incredibly disorienting double vision. Then you add in a dilated pupil that just can't focus properly, and suddenly even something as simple as reading a book becomes almost impossible. All right, next up, we have the trochlear nerve. Now This one's a specialist. It only controls a single muscle, the superior oblique, and that muscle's whole job is to help the eye look down and in. It's a really subtle movement, but it is absolutely critical. So when this one super specialized nerve fails, the result is vertical double vision. You literally see one image stacked right on top of another. And this is just a brilliant illustration of how a specific nerve problem creates a very specific real-world challenge. People with this condition often have a really tough time walking downstairs because they just can't judge where the steps are. And that head tilt you see, that's not a choice. It's the brain's exhausting, desperate attempt to manually fuse those 2 images back into one. Our final pilot is the abducens nerve, and its mission is simple. It has one job and one job only: move the eye outward, away from the nose. Sounds simple, right? But it is so essential. So think about it. If the nerve that pulls the eye outward fails, well, then the muscles pulling it inward are going to win that tug of war. The eye gets stuck, pulled in toward the nose, and the impact? Severe horizontal double vision, especially when you try to look to the side. So, and this is the crucial point, this makes tasks that rely on those side-to-side glances, like driving a car, incredibly dangerous. Okay, so we've seen how damage to the eye's pilots can cause huge problems with control. But what about issues with the eye's actual hardware? Let's shift gears now and look at 2 of the most common blockers of vision that aren't about control, but about clarity and perception: cataracts and glaucoma. A cataract is surprisingly simple to understand. That clear, natural lens inside your eye, it just gets cloudy over time. The best analogy, and it's a perfect one, is trying to look through a foggy or a frosted window. Your entire world just becomes blurry, colors start to look faded, and the glare from lights can be totally blinding, especially at night. Glaucoma is different, and in a lot of ways, it's way more insidious. It doesn't really cause blurriness, at least not at first. Instead, it steals your sight silently, from the edges inward. It's usually caused by increased pressure inside the eye that just slowly, quietly damages the optic nerve. The real danger here is that people often don't even notice it's happening until significant, irreversible damage has already been done, creating that dangerous tunnel vision effect. Okay, let's do a super quick recap. As you can see, those 3 nerve palsies each create their own distinct type of double vision. A cataract, on the other hand, just creates an overall blur, almost like there's a film over everything you see. And glaucoma? It's the silent thief that steals your vision from the outside in. Each one presents a totally unique challenge. And now, we get to the really hopeful part of our story. Because while these conditions can be absolutely devastating, modern ophthalmology has this incredible toolkit to fight back and actually restore what's been lost. So how exactly is sight restored? Well, the solutions are just as precise as the problems they're meant to solve. For a cataract, that clouded lens is surgically removed and replaced with a clear artificial one. And this can restore vision almost overnight. It's amazing. If the cornea itself, the eye's front window, is the problem, a transplant called a keratoscopy can replace it with a healthy donor cornea. And for a real crisis, like a detached retina, surgeons have these incredible techniques to gently secure it right back into place, restoring that vital connection to the brain. Now, I just mentioned keratoplasty, which relies on a donor cornea. And that brings us to what is maybe the most powerful solution of all, one that depends not just on a surgeon's incredible skill, but on the profound generosity of other people. So what exactly is eye donation? It's really important to be clear about this. It is not the entire eye that gets transplanted. It is the cornea, that clear, protective outer layer. After death, it can be given to someone whose own cornea has become cloudy or scarred, and it allows them to see the world clearly once again. The process itself is very straightforward, and it's always handled with the utmost respect. Really, the key is just letting an eye bank know within about 6 hours. From there, a team handles the procedure with just incredible care, making absolutely sure there's no disfigurement to the donor. It's a simple process that has a truly life-changing impact. And this is the most incredible part. Because we all have 2 eyes, a single person's donation can restore sight for 2 different people. Just think about that for a second. One single act of generosity creating 2 futures filled with sight. What a truly remarkable legacy that is. Which really just leaves us with a final thought. Our vision is this gift that we so often take for granted, this complex dance of nerves and lenses. But for some, that gift can be renewed. And it just goes to prove that sometimes the end of one person's journey can be the very thing that lights the beginning of another's.